Hello everyone. In this video, let's discuss about the partition list. Given the head of a linked list and a value x, partition it such that all nodes less than x come before nodes greater than or equal to x. You should preserve the original relative order of the nodes in each of the two partitions. So here they have given a linked list with the elements of 1, 4, 3, 2, 5, 2. And the value of x is equal to 3, which means the value which is less than 3 should be in the beginning, which is 1, the next 2, next this 2, then 4, 3, 5. And here we have to preserve the original relative order of the nodes. Okay, let's discuss this logic in detail. Okay. So first I have to create one dummy node. So that is list node, smaller node equal to new list node. I'll initialize the value as -1. So why are we having this dummy node in the sense to store all the smaller values of x. So I'll initialize the value as -1 and this will have the value as null. I'll have this value as 1500. So this I'll give the name as smaller node. Okay. Now what I'm going to do is I'm going to take one more object called smaller and I'm going to point to the smaller node. List to node smaller equal to smaller node. So smaller node is 1500. So here I'm going to point an object called smaller. Okay. Smaller is pointing here. Next what I have to do, I have to take one more object called greater. So I'll be creating a node, dummy node called greater node to store the greater node's value, which is the value which is greater than x. So let's copy this one. I'll create one more node. I'll give -1 null. I'll give the address to be 1800. I'll give the name of this node to be greater node. Okay. Fine. And I'm going to take one more object called a greater and that is going to point to this node. So list node greater equal to greater node. Okay. Fine. I've got two nodes. Now I'll take one more object called current to start the iteration from the first node of the linked list. So list node current equal to head. Wherever head is pointing, that will be pointed by the current. Okay. So current is pointing to first node. So now take a loop and start the iteration. So while current not equal to null, check the condition if the current is not equal to null. Yes, current is not equal to null. If current is not equal to null, I have to check one condition, that if current dot val is less than x. Check the condition. Current is pointing to the first node called 1000. Current dot val is 1. Whether 1 is less than 3? Yes, 1 is less than 3. So this node has to be joined with the smaller node. So what I'm going to do is smaller dot next is equal to current. So current is pointing to the node called 1000. So that 1000 will be stored in smaller dot next. So here I'll be storing the value called 1000. Afterwards, smaller has to be moved by one step. So smaller equal to smaller dot next. So smaller is 1500, dot next is 1000. So smaller will be moved to the node called 1000. Done. Afterwards, I have to go to the next node. Current has to be moved to the next node, right? So current equal to current dot next. That's all. Current from here I'll move to the next node. Check the loop again. Current not equal to null. Yes, current is not equal to null. So if the current is not equal to null, go for the loop. Current dot val is less than x. 4 less than 3? No, 4 is not less than 3. If that is not true, what I have to do? I have to go to the else part. In the else part, what I'm going to do? In the else part, what I have to do? This value is greater than x. So I'll be storing it in the greater part. Greater dot next is equal to current. So greater is 1800, greater dot next is here. Here I'll be storing the current nodes value. What is the current nodes value? 2000. 2000 will be stored here. Fine. Afterwards, I have to move greater by next step. So greater equal to greater dot next. Greater equal to greater dot next. So greater will be moved to greater dot next. So that is 2000. Greater will be point to 2000. Now go for the next node. Current will be moved to the next node. Current not equal to null. Yes, current is not equal to null. Condition true. So current dot value is 3. 3 less than 3. Condition is false. If the condition is false, I'll go to the else part. In greater dot next, so which is greater dot next, I have to store the current value. Current is 3000. 3000 has to be stored in greater dot next. Afterwards, I have to move greater by next step. Greater equal to greater dot next. So greater from 2000 will move to 3000. Afterwards, current has to be moved by one step. So from here, current will be moved to next node. Now check the loop again. Current not equal to null. Yes, current is not equal to null. Current dot value less than x. 2 less than 3. Yes, 2 is less than 3. If this is the case, I have to store this node's address in the smaller node. So smaller dot next. Smaller is 1000. 1000 dot next. Here I have to store 4000. Here I have to store 4000. After this, smaller equal to smaller dot next. Smaller from here, it will be moved to 4000. Fine. Now current equal to current dot next. From here, current will be moved to the next node called 5000. Check whether current not equal to null. Yes, current is not equal to null. 5000 is not equal to null. So I'll go inside. Current dot val 5 less than 3. No, 5 is not less than 3. So this is a greater node. So what I'm going to do in greater dot next, I'm going to store the current value. So current is 5000. That I'm going to take. I'm going to store in greater dot next. So here I'll be storing the value called 5000. Okay. Afterwards, what I'm going to do? Greater equal to greater dot next. So greater will be moved to the node called 5000. Now what I'm going to do? Current will be moved to next step. Okay. So current not equal to null. Yes, current is not equal to null. What I'm going to do? I'm going to check the condition. 2 less than 3. Current dot value is 2. 2 less than 3. Yes, 2 is less than 3. This has to be updated in the smaller node. In smaller dot next, I have to update this node. That is, current is 6000 will be taken and that will be updated in smaller dot next. Here I'll be updating 6000 and I'll move smaller by one step. That is, I'll be pointing to 6000. Now current equal to current dot next. Current will be moved to null. Now when I come for the loop, condition becomes false because current is equal to null. I'll come out of the loop. After coming out of the loop, I have to join smaller node and the greater node. For that, smaller dot next is equal to greater node dot next. So in the greater node, next to what I have 2000. So this will be taken. That will be stored in smaller dot next. So 2000 will be taken and stored in smaller dot next. So here I'll be storing 2000. Afterwards, as greater is pointing to the last node of the linked list, right? So for that, greater dot next is equal to null. So greater is pointing to this place. Dot next here, I should make this as null because this is the last node of the linked list. Finally, I have written the first node. So the first node is nothing but return smaller node dot next. So smaller node is this 1500 dot next 1000. So 1000 is the first node where I have the value. Let's traverse the linked list now. I'll go to the first node called 1000. I'll go to the first node called 1000. I'll take the value 1. I'll take the value 1. Fine. Then after this, I have to go to the next node as 4000. I'll go to the memory location called 4000. I'll get the value 2. Okay, I've got the value 2. Then I'll go to the next node called 6000. I'll get the value called 2. Next, I'll go to the memory location called 2000. I'll take the value called 4. Okay. Then I'll go to the memory location called 3000. Okay. Then I'll go to the memory location called 5000. Okay, I've got the value called 5. then it is null. That states that I am the end of the linked list. My output is 122435. 122435. That's all. This is the logic of the program. Let's try to implement it as a program now. If we are clear with the logic, first I have to create smaller node. That is dummy node for smaller node. So smaller node is equal to new list node -1. And then I'm going to take an object called smaller. Here I'll be pointing the smaller node's address. Similarly, I'll go for a greater node. I'll initialize the value as -1. I'll be taking one more object called greater, where I'll be pointing the greater node's address. Fine. I'm going to take one more object called current to start the iteration of the linked list, and head value will be stored in current. While current not equal to null. If current is not equal to null, what I have to do? I have to check the value that if current dot value is less than x. If it is less than x, in smaller dot next, I have to update the current value and I have to move smaller by one step. Smaller equal to smaller dot next. In case the condition is false, that value belongs to the greater node. So greater dot next is equal to current, and I have to move greater by one step. Greater equal to greater dot next. After this, I have to move current by one step as usual. That's all. Once the iteration got over, I have to merge the smaller node and the greater node. So smaller dot next is equal to greater node dot next. So in the greater node's address part, what I have, that has to be stored here. And I have to make the last node as null. So where I can point the last node? Greater. So greater dot next is equal to null. Finally, I have to return the smaller node dot next. Smaller node dot next. This will help us to find the first node of the linked list. That's all. Let's run the code now. As it passes the test cases, let's submit the code. As it passes all the test cases. That's all.